Dinesh, come front now. No issues, come. పర్లేదు బుక్స్ తీసుకొచ్చే ముందుకి. సో good evening. So welcome to NEET World Institute and NEET World YouTube channel. So in this class now we are going to concentrate on the motion in straight line, like motion in one dimension we'll say. Okay, so let's start with the class, right? I hope you guys are getting the voice right. Yes. So let's start with the class now. So motion in a straight line. Okay. అంటే మోషన్ అంటే ఏంటి, అంటే రెస్ట్ అంటే ఏంటి, దెన్ వాట్ ఈస్ ద మీనింగ్ ఆఫ్ స్ట్రైట్ లైన్. ఓకే, లెట్ మీ గివ్ అ బేసిక్ ఎక్స్ప్లెనేషన్ ఆఫ్ ది గివెన్ టాపిక్ హియర్. ఓకే, సో మోషన్ ఇస్ నథింగ్ బట్ ఆబ్జెక్ట్ ఈస్ మూవింగ్ అని చెప్తాం కదా. ఆబ్జెక్ట్ మూవ్ అవుతే అది మోషన్ అని చెప్తాం. అంటే స్ట్రైట్ లైన్ అంటే ఏంటి, ఒక స్ట్రైట్ పాత్. అప్పుడు ఒక ఆబ్జెక్ట్ ఒక స్ట్రైట్ పాత్లో మూవ్ అవుతూ ఉంటే అది మోషన్ ఇన్ అ స్ట్రైట్ లైన్, లైక్ ఆబ్జెక్ట్ ఇస్ ఇన్ మోషన్ in straight line we'll say, right? So let me give a basic idea about what is motion and what is rest. దాని తర్వాత ఫిజికల్ క్వాంటిటీ అంటే ఏంటి, దెన్ ఫిజికల్ క్వాంటిటీస్లో స్కేలార్ అంటే ఏంటి, వెక్టార్స్ అంటే ఏంటి చూద్దాం. ఓకేనా. సో మోషన్ అండ్ రెస్ట్. ఈ మోషన్ అండ్ రెస్ట్, when we talk about these terms, no, both are relative terms. అంటే ఫర్ ఎగ్జాంపుల్ ఒక బస్ ఉంది, ఒక బస్లో 2 persons ట్రావెల్ చేస్తున్నారు, ఒక డ్రైవర్ ఒక కండక్టర్ అని ఉన్నారు. సో బోత్ ఆర్ సిట్టింగ్ అడ్జసెంట్ సైడ్. ఓకేనా. ఇంకొక పర్సన్ బయట నుండి చూస్తున్నాడు, వాచ్ చేస్తున్నాడు. లెట్ మీ టేక్ దిస్ పర్సన్ ఏ, పర్సన్ బి అండ్ పర్సన్ సి. Okay, so person A and person B both are traveling in a bus. Let me take that person are bus, like bus driver and bus conductors. Okay na. Inkoka person Dinesh is watching from outside. Okay na. Okay Dinesh, nu chustunavu ikkada bus move avutunnadi, bus la unde iddaru కూర్చున్నారు. Person A is watching person B and person B is watching person A and bus is in motion. Can I say person A and person B are in motion with respect to them? Is in motion. అంటే person A person B ని వాచ్ చేస్తున్నాడు, person B person A ని వాచ్ చేస్తున్నారు. According to them, according to each other, they are in motion or they are in rest? They are in rest. Let me give a explanation why we are saying that is in rest and why it's in motion we'll say. Okay, I'll give a definition of that one. So yes, hi. When object changes its position with respect to time. Okay na. సెకండ్ పాయింట్ ఏమంటే when object does not or doesn't change its position with respect to, when doesn't change its position with respect to ఓకేనా. ఫస్ట్ డెఫినేషన్ దేని డినోట్ చేస్తుందంటే లైక్ ఆబ్జెక్ట్ చేంజెస్ ఇట్స్ పొజిషన్ విత్ రెస్పెక్ట్ టు టైమ్ అంటే ఆబ్జెక్ట్ ఈస్ ఇన్ మోషన్. ఇక్కడ వెన్ ఆబ్జెక్ట్ డజంట్ చేంజ్ ఇట్స్ పొజిషన్ విత్ రెస్పెక్ట్ టు టైమ్ అంటే ఆబ్జెక్ట్ ఈస్ ఇన్ రెస్ట్. సో పర్సన్ ఏ పర్సన్ బి ఫస్ట్ సీట్లో సెకండ్ సీట్లో కూర్చున్నారు, బట్ బస్ మూవ్ అవుతుంది. బట్ బస్ మూవ్ అవుతే కూడా ఆ ఫస్ట్ సీట్లో కూర్చున్న పర్సన్ ఫస్ట్ సీట్లోనే కూర్చున్నారు, సెకండ్ సీట్లో కూర్చున్న పర్సన్ సెకండ్ సీట్లోనే కూర్చున్నారు. ఓకేనా. వెన్ అ పర్సన్ లైక్ వెన్ అ బస్ ఈస్ మూవింగ్ ఆల్సో a person A sitting in the same place, person B also sitting in the same place. So according to the definition what we can say, when object doesn't change its position with respect to time, I can say object is in rest. ఇప్పుడు బస్ మూవ్ అవుతుంది, లైక్ లెట్ మీ టేక్ ద బస్ ఇస్ మూవింగ్ ఇన్ దిస్ డైరెక్షన్. ఆఫ్టర్ సమ్ టైమ్ బస్ ఇస్ ఇన్ దిస్ పొజిషన్. C is standing here only. Initially C was seeing straight and after some time he was seeing somewhere like this. Okay. When time passes, the position of A and B also changes there. Then I can say that according to C, A and B are in motion, but according to A, B is in rest, and according to B, A is in rest. Okay. So we can say that according to A, B is in rest. Why? Because it doesn't change its position. Okay. But according to C, A or B is in motion because it changes its position as time passes. Okay. So this is the basic idea about what is rest and what is motion. Okay. So the next thing what we are going to see is physical quantity. Okay. What is the meaning of physical quantity? Physical quantity. Okay. Physical quantity is nothing but ఇప్పుడు anything that can be measured. Okay. Anything that can be measured is called as physical quantity. Let me give a definition here. Anything that can be measured is called as physical quantity. Okay na. And before that I'll give a one more important point. ikkada motion and rest gurinchi chusam kada. This motion and rest no both are relative terms. Okay. So both are relative terms we'll say. So motion and rest both are relative terms. Okay. Both are relative terms. Dinesh Karthik. Hi. Come. Sit down. Okay. So motion and rest are both are relative terms we'll say. And when we talk about motion and rest no, they are based on the reference frame we'll say. Okay. From the reference frame only we can say that whether the object is in motion, object is in rest. So based on reference frame we can say whether the object is in motion or in rest. Okay. I'll ask question. Harish, DK. Okay na? Chudam. Listen. I'll explain once again. Those who came late, no? Listen here. సో మనం మోషన్ అండ్ స్ట్రైట్ లైన్ చాప్టర్ చూద్దాం, ఓకేనా. సో మోషన్ అంటే ఆబ్జెక్ట్ ఇస్ ఇన్ మూవింగ్, ఆబ్జెక్ట్ ఇస్ మూవింగ్, అండ్ స్ట్రైట్ లైన్ అంటే ఏంటి, ఆబ్జెక్ట్ ఇస్ గోయింగ్ ఇన్ అ స్ట్రైట్ లైన్ విల్ సే, రైట్. సో లెట్ మీ టాక్ అబౌట్ వాట్ ఈస్ మోషన్ and what is rest here. So when object changes its position with respect to time, I can say object is in motion. As time passes, no, the position of the object changes. If time going, like time is passing, okay na, time is passing and the object doesn't change its position. Like for example, Arish, you came now, like from downstairs to upstairs you came, right. As time passes, you were walking towards up. But when we talk about these benches, no, in the classes, as time passes, whether these benches moving? No. Then we can say that benches are in rest. And as the same time, when Arish is coming from the downstairs to upstairs, we can say that Arish is in motion, right, no. So when object changes its position, a position ante enti oka point unti inkoka point ki change avutundi. అప్పుడు ఆబ్జెక్ట్ అంటే టైం పాస్ అవుతే లైక్ ఆబ్జెక్ట్ చేంజెస్ ఇస్ పొజిషన్ అవుతే అది రెస్ట్ అండ్ ఐ మీన్ మోషన్ అని చెప్తాం. సపోజ్ ఇది చేంజ్ అవ్వకపోతే రెస్ట్, పొజిషన్ చేంజ్ అవ్వలేదు. ఇప్పుడు ఇక్కడ ఒక ఎగ్జాంపుల్ తీసుకుంటాం. సో పర్సన్ ఏ అండ్ బి అని ఉన్నారు ఇక్కడ, అండ్ పర్సన్ సి. పర్సన్ ఏ అండ్ బి ఆర్ ఇన్ బస్. సో దీస్ టూ పర్సన్స్ ఆర్ సిట్టింగ్ ఇన్ ది సేమ్ ప్లేస్, అండ్ వెన్ టైమ్ పాసెస్ అండ్ బస్ ఇస్ మూవింగ్, బట్ person A and B are in same position, but we can say that both are in rest. Then according to C, person A and B are in motion, because initially they were in this place. When time passes, bus is also moving. So according to C, A and B are in motion, okay. But according to B and B, A is in rest, according to A, B is in rest, okay. So this was the point we were discussing. And motion and rest are relative terms. Motion and rest both are relative terms, we will say. By relating the terms or relating the things only, we can say that whether the object is in motion or in rest, okay. So based on the reference frame, so based on the reference frame in the sense, a person in the bus and person on the ground. So what frame we are using here? One is ground, one is bus. So we are connecting the two frames there, right. So based on this based on some frames only, we can say that we can judge that object is in motion or object is in rest, right. So this is about a basic information about motion and rest. So the next thing what we are seeing is physical quantity. Anything that can be measured is called physical quantity, we'll say, okay. So for example, ఈ వాటర్ బాటిల్ ఉంది, ఓకేనా. ఈ వాటర్ బాటిల్లో నేను వాటర్ ఫిల్ చేస్తాను, ఐఎమ్ ఫిల్లింగ్ ది వాటర్. So this is 2 liter bottle. Look, like if I fill up to this point, I can say 2 liters. Okay, I can measure something. Suppose if I am having this pen or the remote, this pen is there and this remote is there. If I want to calculate what is the length of this one, or if I want to calculate what is the weight of this one, or what is the mass of this one, okay, mass calculate cheyochu. Yes, no, we can calculate the mass. So we can calculate the length. Okay, fine. Now Arish is there and Dinesh also is there. They are very hungry, okay. Can we calculate what is the hungry of Arish, and can we calculate what is the hungry of Dinesh? No. So there is something we cannot measure. For example, like you can say like what is the thing we cannot measure? Feelings we cannot measure. So Dinesh, any example? Emotions, same thing, right, no. So like happiness we cannot measure, anger we cannot measure, hungry we cannot measure. Something that cannot be measured, we cannot call them as physical quantity, right. So that can be measured only, we can call them as physical quantity. Now this physical quantity is there, no. This physical quantity has been divided into 2 types, okay. Listen here. The first one is scalar quantity, will say. Okay. Second one is vector quantity. Scalar quantity and vector quantity. ఇప్పుడు స్కేలార్ క్వాంటిటీ అంటే ఏంటి, వెక్టార్ క్వాంటిటీ అంటే ఏంటి? లైక్ ఈ ఫిజికల్ క్వాంటిటీలో ఈ టూ క్వాంటిటీస్ ఉంది. స్కేలార్ క్వాంటిటీలో ఓన్లీ నంబర్స్, ఓన్లీ మ్యాగ్నిట్యూడ్ విల్ మెషర్. ఓకే, we will measure only magnitude. ఓకే, సో ఓన్లీ మ్యాగ్నిట్యూడ్ అంటే ఒక ఆబ్జెక్ట్ ఇప్పుడు మనం క్యాల్కులేట్ చేస్తాం. 2 liters, weight of this is 10 gram, length of the remote is 20 centimeter. అంటే ఇక్కడ ఏం చూస్తున్నాం, 2 liters, 20 grams, then 20 centimeter. ఇప్పుడు నార్మల్గా టూ చెప్తే ఒక నంబర్ అంతే, బట్ ఒక యూనిట్తో మెషర్ చేస్తున్నాం కదా, యూనిట్ అని ఉండాలి అండ్ ది నంబర్ ఆల్సో షుడ్ బి దేర్. సో ఇక్కడ ఏం చెప్పాలి మనం, లైక్ a number also should be there and the unit also should be there. But when we come to vector quantity, unit also should be there, number also should be there, including direction should be there. Okay, so I'll give a thing here. We have both magnitude and direction. Okay, both magnitude and direction. So in the scalar quantity, like unit will be there. Okay, first thing, and the second thing is number also will be there. In this vector quantity, we will be having units, then we will be having numbers, then we will be having direction. Okay, so for example, person is walking 2 kilometer, person is walking 2 kilometer east direction. Two things. Example 1 is person is walking 2 kilometers. Second example, person is walking 2 kilometer east direction. ఈ 2 ఎగ్జాంపుల్కి ఏం డిఫరెన్స్ ఉంది ఇక్కడ, 2 ఎగ్జాంపుల్స్కి ఏం డిఫరెన్స్ ఉంది ఇక్కడ, టెల్. ఫస్ట్ వన్లో వాక్, నార్మల్గా వాక్ అని చెప్పినారు 2 kilometers. అంటే ఏం యాడ్ అయింది ఇక్కడ, డైరెక్షన్ యాడ్ అయింది. ఫస్ట్ దీంట్లో డైరెక్షన్ యాడ్ అవ్వలేదు, అంటే ఒక జస్ట్ 2 ప్లస్ యూనిట్ చెప్పాడు. 2 అనేది ఏంటి, ఒక నంబర్, కిలోమీటర్ అనేది ఏంటి, ఒక యూనిట్. సో ఒక యూనిట్ ఒక నంబర్ మాత్రం మనం మెన్షన్ చేసినామంటే అది స్కేలార్ అని చెప్తాం. అప్పుడు ఇది ఎగ్జాంపుల్ 1, ఇట్స్ అ వెక్టర్ ఆర్ స్కేలార్, స్కేలార్. సెకండ్ ఎగ్జాంపుల్ 2 అనేది ఒక నంబర్ ఉంది, కిలోమీటర్ యూనిట్ ఆల్సో ఇస్ దేర్, అండ్ ఈస్ట్ is nothing but one direction, right? No, so number is there, unit is there, and direction also is there. So now which quantity is this, vector quantity. Okay, can you frame any 2 examples for scalar and vector? Scalar, yes, not based on this one, anything other than this one. Correct, like it is mass, length, time, okay, that one, velocity, acceleration, okay, fine. But I'm asking about anything that can be framed as an example, like based on your surroundings. Yes, scalar వచ్చేసి he is driving a car, he is driving a car. Vector వచ్చేసి he is driving a car for an hour, he is driving a car for hours. We are mentioning only time, right? That's it. No, we are not mentioning direction, right there. Huh. Tell. No issues. Frame. First example, like he is driving. How many kilometers he is driving? 2 kilometers is driving. Okay. So anything like that can be added there to frame as a vector quantity?
He's driving a car
Okay.
to east.
Same thing. You just added a person driving a car. East direction.
What direction means we can take the places?
Like I'm giving a condition here. అంటే నువ్వు ఈస్ట్ వెస్ట్ నార్త్ సౌత్ యూస్ చేయకుండా వేరే ఏదైనా చెప్పాలి.
Means we can take places, sir.
Places అంటే like we can say that is walking in a right direction, left direction, straight, backward. We are mentioning something a direction కదా. ఒక డైరెక్షన్తో మెన్షన్ చేసేటప్పుడు అది ఏం చెప్తాం, అది వెక్టర్. ఈవెన్ లైక్ వెన్ ఐఎమ్ టాకింగ్ అబౌట్ స్ట్రైట్ అంటే ఐ షుడ్ సీ ఫ్రంట్. When I am talking about right side, I should see right side. When I am talking about left side, I should see left side. Right now, when I am talking about backward means I need to see back side. Right?
Can we tell like
Yes, like a person is walking straight and then you have taken left and then you have taken right. Straight, left, right.
we can tell like
Ronaldo.
curve shot is very
Curved shot. Yes. Good. Okay. So understood now? So any other example from Dinesh side? So can we say that Dinesh got sick and he have went to hospital, but can we say that adding some directions, he have went to hospital like from Narayanaguda to so okay, from his home to okay, if from his home if we take left and 2 kilometers straight, then right direction. Okay, so you are mentioning some directions here. So whenever you are mentioning some directions, we can say that it's a vector. And simply like Dinesh went to hospital means we can say it's a scalar quantity, but I need to have some kilometers. 2 kilometers you told. Okay, that's good. Kalpana Sharma, voice is very, yeah, I guess it's clear now. Yeah, it's clear, I guess. Okay, so can we go for the some other examples like in mathematical terms, no? So we have this pi value. Listen here. We have this pi value, no, in max. What is the value of pi? 3.14, or else we can say that is 22/7. So whether this pi, it's a scalar, can I say? Yes, because it is only number, right? So only number we can say it's a scalar quantity, like only magnitude, right? In the previous case we were discussing, we will measure only magnitude, we will have only magnitude. So we will have only magnitude means that is a scalar quantity we told, right? So pi is a number, then any number comes under scalar, but number with direction comes with vector. Okay, can we frame an example, other examples? Once you check the voice. So voice is coming, I guess. Yeah, it's clear now. Yes, no? It's clear. Okay, fine. Okay guys, listen here. Now we'll go with a basic term of a position, displacement and then distance here. Okay, position means like in a space we will point out. Space means nothing but here the x, y, z axis are there, no? X axis, y axis, z axis. So whenever we talk about anything, we point them in a space. Everything is a 3D, no? 3D. Like if we talk about the corner of the room, like 1 dimension, 2 dimension, 3 dimension, like 3 axes are there, right? So if I talk about that corner, so axis 1, axis 2, axis 3 downwards, right? So one like this and one is towards down. So can I say like this, x axis, y axis, z axis? Okay, so usually we will point a position in a space. So if I talk about a position of an object which is A, we will always connect with them in a origin O. So let me take this as position OA. Okay, OA. And I'll give one more point here. Whenever we talk about a vector, no, and scalar, if I talk about A is equals to 5. Okay, A is equals to 5. And if I keep a vector like this, which means A is 5 meter or 5, let me take A is equals to 5 meter. Second one is A vector is equals to 5 meter in east direction, in east. So whenever we are talking about a vector, we need to have this variable, that a bar should be there upon the a variable. So if a bar is not there, then we can say it's not a vector quantity. Okay, so whenever we talk about a vector quantity means the bar should be there. If a bar, if we see, that will be a vector quantity. Okay, so if bar is not there, then we can say it's a scalar quantity, we'll say. Okay, so now A is equals to pi. Vector or scalar? Scalar, because it's a number 3.14, or else I can say it is 22/7. Done. Now I'm talking about a position. This position, displacement, velocity, acceleration, everything is a vector quantity. Okay, position, displacement, velocity, acceleration, everything is a vector quantity. Then I should denote them with a bar, no? I am talking about a position. So OA is a position, right? So from point O to A, so this A can be said as x1, y1, z1. As time passes, position of A has been changed here. Okay, let me take this as position B. So I'm calculating the position B also with x and y, x, y, z. So x2, y2, z2. So position A ekkada em తీసుకున్నా x1, y1, y2, sorry, z1, x1, y1, z1, here x2, y2, z2. Okay, ఇది ఒక పొజిషన్, ఇది ఒక పొజిషన్. So let me take this as OB. Okay, so as time passes, no, like position also changing. When a position changes, no, I can say it is a displacement. When position changes, it is displacement. When position changes with respect to time, if I talk it, that is velocity, we will say. Okay, let me give an explanation here. Displacement and distance here. So distance, okay, distance and displacement. yes. So distance and displacement here. So distance ante actual path traveled, displacement ante shortest path traveled, a basic idea. So this is actual path travel చెప్తాం, actual path traveled, and this is shortest path traveled. Okay Dinesh, from third floor to ground floor, how many ways you can go? So one is lift and one is staircase you can go. Which is the actual path, Dinesh? Staircase. And which is the shortest path here? Lift. And one more path also it's there. So the fire exit path, that also is there, right? So in this three ways we have traveled. So which is the longest distance and which is the actual thing we are traveling? Actual thing is the staircase we are traveling, right now. And second thing is lift. So I can say that actual path traveled by a person, actual path traveled by Dinesh is distance. The shortest path traveled by Dinesh is displacement, right? And here I can say that distance can be zero. Distance can be zero. How? If a person doesn't travel, I can say distance is not zero. I mean it's zero. Yes or no? When a person is not traveling, he is not moving. Okay, ఇప్పుడు టైం చేంజ్ అవుతూనే ఉంది. ఇప్పుడు ఎంత టైం? 6:36. ఒక 5 minutes తర్వాత ఆ పర్సన్ అక్కడే ఉన్నాడంటే ఐఎమ్ టాకింగ్ అబౌట్ వాట్ ఈస్ ది డిస్టెన్స్ ఆఫ్ ది పర్సన్ ట్రావెల్డ్ ఇన్ దిస్ 5 minutes. ఐ కెన్ సే పర్సన్ ట్రావెల్డ్ 0 meter or 0 kilometer, right? When time passes and the position of the person doesn't change, I can say distance is 0. So distance can be 0 also, and distance is always positive term. Okay, next point of displacement is, yes, it can be 0 also and it can be negative also. Okay, so negative, positive and 0, 2, and here 0 and positive. These are the two cases and these are the three cases here. So from this analysis we can say that distance is always greater than or equals to displacement. Can we see an example here? Can we see an example here? Can we take a scale, okay, which is having both positive and negative. Integers are there, no? Integers means only the positive numbers and negative number including 0 also will be there. No decimal points. That is integer will say. So a person is standing here. Ante ekkada origin la. Origin means the point 0. And it started traveling towards right side. Towards right side ante positive direction lo veltunnadu. How much meter? 5 meter he went. He started traveling 5 meter in the right direction, and then he have taken U-turn and started traveling towards left until -3 meter. Okay, so he have stopped here. Initially he started from point A, so point A to B, then B to C came. నేను A నుండి B కి వెళ్ళి మళ్ళీ C కి రావచ్చు, లేకపోతే A నుండి C కూడా రావచ్చు, right? So how, like, which one is the shortest and which one is the actual path? Actual is A to B, B to C, right? And shortest is A to C, right? So can I say this is 5 meter again plus 5 meter plus 3 meter. So distance is equals to O to A, that is O to B, sorry, AB plus BA plus AC. How much it is? 5 plus 5 plus 3, which is nothing but 13 meter. Okay, But whenever we are talking about displacement, no, I need to talk with the direction. So always consider this is my positive direction when I am talking about upward. When I am talking about right side, it is positive direction. When I am talking about left side, negative, downward, negative. Okay. So one more point, when we talk about the displacement, delta x, like change in position. Okay. Delta x is nothing but change in position. Okay, which is x final minus x initial. Final position minus initial position, will say. I will write here. So change in position is equals to final position minus initial position. ఓకే, సో ఇక్కడ ఇదే ఫార్ములా మనం ఎప్పుడైనా డిస్ప్లేస్మెంట్ గురించి మాట్లాడేటప్పుడు. ఇక్కడ ఫైనల్ పొజిషన్ ఏంటి? ఇక్కడ ఫైనల్ పొజిషన్ ఏంటి? -3. ఇనిషియల్ పొజిషన్ ఏంటి? 0. సో డిస్ప్లేస్మెంట్ is equals to final position x final minus x initial position. X final is -3, x initial is 0. So answer is -3 meter. Okay, you can copy down this one. Yes. No, it's clear, I guess. Okay, so up to this we'll stop for this class, and let's continue with the example part, and what about the velocity, speed in the upcoming classes, right? Okay, let's stop up to here. Thank you guys.